Hey, so today we're going to do some more shortcuts. Yesterday we did side, 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 and we did side, angle, side. So when we did side, angle, side, we had to have an included angle. And our first postulate today talks about an included side instead. So an included side is the common side of two consecutive angles in a polygon. The following postulate uses the idea of an included side. Okay, so here we have our little angle P. Okay, and then we have our little angle Q. And their included side is just this side PQ that is in between those angles. Okay, so if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then we have congruent triangles. And we have this little picture of our matching A and D angles and our congruent C and F angles and their included sides A, C, and D, F. Okay. So here we have a flow proof to complete. We want to prove that triangle XYZ, that's this one, is congruent to triangle VWY. Oh, VYW, excuse me. Let me flip the letters around. Okay, so in order to do this, they've given us some helpful information. We know that angle XYZ is congruent to angle VYW. And you can see that is one of our first steps in our proof. So let's complete that step and write given. Next, I see that segment XY is congruent to segment VY. XY congruent to VY. And I don't see that in the proof yet, and I have another given, so I'm going to put that above the second given. XY is congruent to VY. Okay, now we learned last week about some special properties of isosceles triangles. And if I have two sides congruent, do you guys see this big triangle, the big one here? If I have these two sides marked congruent on that big triangle, my big triangle XYV is isosceles. Okay, so I'm going to say that triangle XYV is isosceles, which I should be able to spell because it's right here underneath. Okay, now that I've shown that XYV is isosceles, I know something special about its little opposite angles. Let me get rid of this red triangle. Okay, I messed up my picture. It's fine. It's fine. It's fine. Their opposite angles are congruent in an isosceles triangle. Okay, so I can say that angle YXZ, or just angle X, is congruent to angle V. Let me mark those with 2 so I don't get them confused with my other congruent angles. And I know that because of the isosceles triangle theorem. Isosceles, whoops, that's, oh my gosh. Isosceles triangle theorem. We had that on our quiz a couple times. Okay, last but not least, I now have a pair of angles, I have a pair of sides, and I have another angle. So let's see if they are the included sides that I've got. So sure enough, my congruent sides right here boop, 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 are included between my congruent angles. It goes angle, side, angle. So I know that these triangles are congruent by the angle, side, angle congruence postulate. Ta-da! Okay, now we want to know if these pairs of triangles can be proved congruent. Can we use angle side angle to prove that triangle K and L? Oh my gosh, I'm flipping letters around like crazy. Do not listen to me. It's NKL. OMG. NKL is congruent to triangle LMN. LMN. Okay. So these two triangles share a side. Boop, 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 and that side is congruent to itself by the reflexive property. I also have two beautiful parallel lines because these sides are parallel to each other. Let me just extend my parallel lines like we practiced. Okay, that congruent side is on my hot pink transversal, and I'm going to shade my interior because it helps my brain. Okay, now inside of my parallel lines in the interior, I have a pair of alternate interior angles. So I know that those two angles are congruent. So I just have an angle, a pair of angles, and a pair of sides, but that is all that I have. I don't have any other information. I don't know about this side. I don't know about this side. Okay, I don't know about this angle. I don't know this angle. I don't know this one, and I don't know this one. So there's just way too many. Oh, I don't know this side either. I have too many question marks. There's too much unknown for me here to be able to use angle, side, angle. So we're going to say, no, we don't have a second angle on the other side of what should be our included side. It's not included in anything, so I'm going to put it in quotes because it doesn't have another angle, but it would be if we had it. So I'm just going to put it in quotes. Included side. All right, let's look at example 3. Can we use angle side angle to prove that these triangles are congruent? Well, they have the same common side, but right now it's not an included side. What I have is angle, angle, and then a side. However, I can use the third angles theorem. Third angles theorem. And say, okay, because I already have two congruent angles in these triangles, my third angles have to be congruent. So I can say that these two are also congruent to each other. And now, I have an included side between my angles. So yes, but only after using the third angles theorem. So that little example brings us to our next congruent shortcut. It's not a postulate like side, 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 angle, or angle, side, angle. It is a theorem, and the proof lies in what we just did with the third angles theorem. It is called angle, angle, side. And remember that that is what we had at the beginning. We had an angle, and a side. Okay? Oh, guys, I just got to, hold on. Okay, sorry, I'm back. Okay. We are going to use the third angles theorem to prove, oh, no, we're not going to. You can, okay? I kind of showed you how that would work. We have another congruence relationship based on angle, side, angle. This theorem is the angle, angle, side congruence theorem. Okay, so here it goes. If two angles and a non-included side of what triangle are congruent to two angles and a non-included side of another triangle, then we have congruent triangles. Okay, so here you can see that I've got angles congruent right there. Boop, 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 boop. And then the side JH or LM is not included between those angles. So basically, guys, what this boils down to is as long as we have two angles, okay, it doesn't matter which side we have. We can have the one included side and use angle, side, angle, or we can have either of the non-included sides, right? And we can prove those triangles congruent between angle, side, angle, and angle, angle, side. All right, so let's look at this proof. We have to prove that triangle JKL is congruent to triangle JML. Okay, we're given that JL bisects KLM, the angle KLM. So we know that these two angles are congruent. Okay, that was given to us. And we just said that those two angles are congruent because it's a bisector. That comes from the definition of an angle bisector. So I'm going to shoot off to the right and just fill in that part of the proof because we already talked about it. So angle KLJ is congruent to angle, let me get them in the right order, MLJ. MLJ. Okay, that takes care of that information. Now they gave us another little tidbit. Angle K is congruent to angle M. You can see that that's marked here on the picture. So we're going to put that for our other given. Angle K is congruent to angle M. All right, now, so far we have, if you're keeping track, an angle, a pair of angles. We have another pair of angles. What we really need is a side somewhere. What we need is a side. All right, so if I look at my picture, I can see that my two triangles share the side JL. Okay, they're sharing a side. So that side is congruent to itself. JL is congruent to JL by the reflexive property of congruence. Reflexive property of congruence. So now we have a side. Now we just have to see if it's an included side or a non-included side, and based on where this is in the notes, I think I have a guess, but we'll see. So here's my angle, and then another angle, and then I have a side. So this is angle, angle, side. It's not included. So this is angle, angle, side. This is the theorem that we just talked about. Ta-da! Okay, the last one. You're not allowed to have favorites, really, but like this is mine because it sounds like a pirate. Pirate. A pirate. Sounds like a pirate. Hypotenuse leg. Hypotenuse leg. Sounds like a pirate name. Okay, so this theorem says that if the hypotenuse and a leg, hence the name hypotenuse leg, of a right triangle. Okay, so it has to be a right triangle. Regular triangles don't have hypotenuses, only right triangles do. So it has to be a right triangle. If the hypotenuse and a leg of one triangle are congruent to the hypotenuse and a leg of another, then we have congruent triangles. And it doesn't matter which leg, it just has to be one of the legs that they have congruent. All right, let's test this one out. All right, so we have to prove that triangle ABD is congruent to triangle CBD. All right, we can do that. They're telling us that angle ADB is a right angle. Thank you very much. And that AB is congruent to CB. Got it. All right, AB congruent to CB, that was just given to us. Okay, and now it's talking about the reflexive property of congruence. So that must be this side that they share. Boop, 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 boop. That side is congruent to itself. So I can say that BD is congruent to BD. And look, the order of B and D in both of the names is the same, so I don't have to worry about flipping the letters around. Okay, next. It tells me that angle ADB is a right angle. Well, that was given to me. So I'm going to write given for that. Now, what I know if that is a right angle, is that BD is perpendicular to AC. And that comes from the definition of perpendicular. So that's my next step. BD is perpendicular to AC. Now that they're perpendicular, I know that this side over here has a right angle too. So I'm going to say that angle CDB is also a right angle. And I got that bit from the definition of perpendicular just like the last step. That one works forwards and backwards. Okay, next. Oh, look, okay. So we had to do two things. Thing number one, we had to get we had to do three things. We had to get a congruent hypotenuse. Okay, that's this. That was given to us. The H was given to us. Okay, we had to get a congruent leg. That's this side right here that was congruent to itself. The last thing that we had to do was show that these were both right angles, that both of the triangles were right triangles, okay? And they only told us that one of those angles was a right angle. So now that we know that our angle BDC is a right angle, we've shown that these are right triangles, and we can use our hypotenuse leg. HL. Okay, that's it. Is that the bottom of the page? Oh, these are fun. Okay, so for these, You'll like these because you don't really have to prove anything. You just have to say which shortcut that we can use. Okay, we do have to code the necessary parts for proving that the triangles are congruent. And if we can't prove them, we're going to tell what we're missing. Okay, so here I have a side and a side. And then by vertical angles theorem, I have these two angles. I also have parallel lines. Okay, so I'm going to extend my parallel lines. Okay, and once I do that, I can shade my interior. Oh, I didn't mean to do that. I meant to do blue. I like shading it blue. Okay, and then I'm going to look for some alternate interior angles in my triangle. So I have a pair right here. Boop, 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 boop. So looking at this, it looks like I have angle, angle, side. And over here, I also have angle, if I can read my own writing, angle, side. So these are congruent by angle, angle, side. All right, next up. Okay, so I have my two congruent sides. Okay, I've got right angle. All right angles are congruent, right? So these two angles are congruent. And then I have, by the reflexive property, this side is congruent to itself. Okay, but this one is tricksy. Okay, look at the order here. I have a side, and then a side, and then an angle. Now, look at the order. The order is messed up. Do you see how it spells a bad word if you go backwards from what I just did? Okay, this is a no bueno one. This one is side, side, angle, and it does not work. Okay, so what information we are missing is, no, just kidding. This one does work. I got so excited thinking it didn't. But look, it's my favorite one. I've got two right angles, okay, and I've got a hypotenuse. That's the long side across from the right angle. I don't know if I mentioned that before. I should have, so sorry if I didn't. Okay, and I have a leg. So this is hypotenuse leg. I was about to say that it was the bad word one, but it's not. It's hypotenuse leg. Arr! Hypotenuse leg will get ya. Okay. Next one. This one, I have all three angles congruent, guys, but I do not have any information about the sides. So we don't know if these are drawn to scale. What might happen is that this triangle is huge and it just has the same angles as the other one. Okay, so these, we can't tell that these are congruent. We can only say that these are similar. Okay, and the information that's missing is that we need a side. Need a side. Because the side is what tells us like how big the triangle is. Okay. Here I have two angles already congruent, two sides congruent, and I have a second pair of angles right here. So this is angle, angle, side. Angle, angle, side. Okay, this one looks like it wants to be hypotenuse leg, but we don't have the hypotenuse. Okay, if we had this side here, we could use side angle side, but we don't have either of those. So the information here is that we either need the other leg, need other leg, or the hypotenuse. So basically we need another side or an angle. We need something. All right, so these two have a pair of congruent sides marked and a pair of congruent angles marked. They also share a side which is congruent to itself. Okay, so this is side, angle, side. Okay, these have two pairs of congruent angles marked. They also share a common side, which is congruent to itself using the reflexive property of congruence. Okay, so I mark that congruent and I say that this is angle, side, angle. Okay, so do you see that how I'm marking these with the coding? Okay, don't forget to code them, that's worth points. So whenever I make these little angle marks or the tick marks, that's the code and that's worth points on your quizzes and tests. So don't forget that, make sure you practice it. Okay, these two also share a side. That side is congruent to itself. So I have three pairs of congruent sides. This one is side, side, side. Okay, this one has a shared side, but we don't have any other sides or any other angles. So these, we can't say that they're congruent. We need another angle or a side. Need another angle or side. Okay, last row. Ooh, I like these. Okay, these parallel line ones, we get to use our Unit 1 stuff too. So draw in your parallel lines, extend them. Okay, shade in your interior. Okay, I'm gonna make my transversal hot pink. Okay, so what you can see here is that I have a pair of congruent angles that are alternate interior angles. Interior to the parallel lines, alternate sides of my transversal. So, whoa, it's still not enough information, guys. I have a shared side too. No, it is enough information. Hold on, wait. Nope, it's not. Okay, this side is congruent to itself, but look at this. Look at the order. I have a side, and then an angle. Okay, look at it backwards. It's the wrong one, like we can't use this one. Okay, let me show you why we can't use this one. We don't have any information about how long this side down here is. All that we know is that these two sides are congruent. So what could happen, because these figures might not be drawn to scale, right, is that this side here could actually be here and congruent to this other side. Now, see how that changes my picture if this was not here anymore. I haven't changed anything in the way my drawing is coded. I still know that these two sides are parallel. Okay, I still have these two congruent sides. I still have this congruent side. I still have my two alternate interior angles congruent, but these triangles are obviously not the same shape. Okay, so this is why we can't use side-side angle. Okay, so this is side-side angle, and it does not work. So we're missing another side or an angle. Missing side or angle. Okay. Let's see. All right, so I have a pair of vertical angles right here. So I have this angle, and that side. This looks like angle, angle, side to me. All right, last but not least, I have two right triangles. So as soon as I see that I have two right triangles, I'm like, ooh, it could be hypotenuse leg. Okay, so I do indeed have the hypotenuse. Okay, those are congruent, and they share a leg. Or it be a wooden leg.